Okay, we're going to go ahead and apply the idea of sampling distributions for a mean and for a proportion. So how do we actually use this in the real world, right? So again, let's look at two examples. We have some data that's been collected about males and females. Here are the average weights and standard deviations, and the data is normally distributed. And so let's imagine the situation where someone's designing a raft, and there's something to consider is the weight of the capacity, right? How much can the raft hold? And so imagine that life rafts are purchased that have a capacity of 16 passengers and a total weight of 2,400 pounds, right? And so suppose a life raft is loaded to capacity, right, with 16 males. We'll have that assumption. So what's the mean weight of the passengers, right? What is the capacity limit, right? The capacity limits assume what? A mean weight of 150 pounds. Think about that, 2,400 divided by 16 males. And so we're looking at the average weight of 150 pounds per person. So now let's think about this question. What's the probability that one randomly selected adult male has a weight greater than 150 pounds? That's a problem we just did in the last section, right? So normal distribution, you go to the normal calculator, you plug in the mean and standard deviation, and you calculate the probability that it's greater than 150. And to remind you what that looks like, you would plug that information into StatCrunch here, your mean, your standard deviation, and where we're calculating what's the probability that actually one individual is more than 150 pounds. And you have almost a 77% chance. This is what it will look like in the art of stat, right? And so the assumptions of a capacity of 16 people, 2,400 pounds, seems maybe a little off because the likelihood of just one person being more than 150 is 77% chance. So something can be off there. Now let's look at the next question here, that where we apply the central limit theorem and have to come up with an adjusted standard deviation here to do the calculation. Find the probability that the sample of 16 randomly selected adult males has a mean weight greater than 150. And so in this case, it's the same calculation. The difference is that we're calculating the probability that the mean of 16 people is greater than 150, the mean, right? And so what you have to do is do that an adjusted standard deviation. You calculate the standard error here, this adjusted standard deviation, you get 10.95. And so what happens is you change your problem. Instead of using the 43.8, you're going to use 10.95 as your standard deviation. That's the key. And so now we're talking about, and that it's greater than 150. There we go. You'll see it's almost a 99% chance that the mean weight of all 16 people is going to be greater than 150, 99.84. And so that's how we would apply that, 99.9984. And you would do the same thing with StatCrunch. You would use the adjusted standard deviation. And then the mean for the sampling distribution is the mu. It's the same value. Now we would apply this same thing to proportions. So let's finish that one here. You have this situation, right, where we're trying to determine the probability, right, that the proportion will be more than 3% away from the true proportion. So what are we looking at here? We're looking at a university, 25,000 students, 73% drive to school, so commuter school. Now suppose the department wants to conduct a survey and ask them whether or not they drive to school to get an idea. So we can look at the sampling distribution, see if that's accurate, right, if that data is accurate. And so you take a sample of 1,000 and we would apply the sampling distribution rules. However, before we do that, we need to verify that our sampling distribution of 1,000 students is normal, right? If we look at the n times p, n times q, and then you get values that are greater than 10, so we know the sampling distribution is normally distributed. We calculate the standard error, the standard deviation for the sampling distribution, you get 0.014. And then you go ahead and calculate it. What's the probability that p hat will be more than 3% away? Now 73% is in the center because that's the That is our P. And so what we're looking at here is we want to know probability being greater than 0.76 and less than 0.70. And so you should get answers of 0.016. What we're going to do is plug this into StatCrunch or the ArtistStat using our mean and standard deviation for the sampling distribution. So this is what it looks like. And that's where I get my 0.016 right there. There's your mean, standard deviation, and 0.70 because we were looking at 0.73 in the middle and 3% away. And then you change the other value to 76 and then a greater than. And you see it's symmetric, so that's why you get the same value. And so that's why you get your 0.016 and 0.016. So putting that together, you get a 0.032 or 3.2% would be our answer. I'll just display those now you try problems so that you can check your answers there. I'll leave it up real quick. You can pause and take a look at that. But those are the answers to those now you try questions.